Okay, I have a rigid body here. It's got a thrust bearing at A. We'll talk about what that means exactly in a second. And then it's got a cable at BC and a load of 80 as shown there. So we're going to start with the free body diagram as we always do. So we've got the 80 pounds already shown. I have a tension that acts straight up that I'll put right there. Now let's talk about what's going on at the thrust bearing. The thrust bearing means that there is a thrust force right there. Okay. If it's not a thrust bearing, that would be free to slide along the y-axis. But with a thrust bearing, it can't move in the y direction. Therefore, there is a thrust force there in the y direction at A. Now, obviously, I can't move in the x or z direction, so I've got an AX and an AZ there as well. Okay, now let's talk about the rotation. Clearly, it's free to rotate about the y-axis. However, I can't rotate either about the x or the z-axis. So I'm going to have a reaction moment MAZ and a reaction moment MAX as shown there. That should be an A, not an X. Okay, so there is what my reaction forces look like. So all my forces are really easy. I don't need to write any force in Cartesian form. So let's just start summing our forces in the x, y, and z direction. In the x direction, I have AX. End of story. Equals 0. So I hope they're all this easy. I don't think they will be. I know that the force in the x direction is then x. I have AY. Also 0. Wow. This is where my luck changes. I've got a whole bunch in the z direction, so I have AZ. I have my tension, and I have 80 pounds right there. Okay, so I've got AX and AY. They both equal 0. Oops, I forgot to put the X, or I'm sorry, the Z component there. But so I've got one equation left, two unknowns. I need more equations. I'm going to go ahead and sum my moments. I'm going to do it about point A. I've got the most unknowns there, even though I guess I know two of them now, but I'm still going to go with that one about the A-axis. I do not want to forget my reaction moments. I got to include those couple moments, which I've got in the X direction and the Z direction. Okay, then I've got my 80-pound force and my tension. Okay, my 80-pound force is going to be, excuse me, my 80-pound force, is going to be plus negative 1.5 in the I. So I go 1.5 in the X direction and then 6 in the J direction. And I'm going to cross that with the minus 80 in the K direction. Then I also have this will be minus 3 in the I to go to the tension, okay, plus 6 in the J. And I'm going to cross that with positive T in the K direction. Okay, so we'll do these two cross products. This one here becomes negative 480 I when I do the cross product and minus 120 in the J direction. This cross product right here becomes 6T in the I direction plus 3T in the J direction. So now that I've got those, I can go ahead and bust out and break out my X components. So I take all my I components, which will be MAX minus 480 plus 6T equals 0. I've got MAY, so I'm going to add up all my J components, which will be minus 120 and plus 3T equals 0. Those are all my J components, and then do all my K components right here, where I will have MAZ. I will have, and that's it. So that one becomes very easy. MAZ equals 0. From here, I learned that T equals 40 pounds. Now that I know T is 40 pounds, I can find that MAX is 240 foot-pounds. And then from this guy up here, I can learn that AZ equals, did I find it? I didn't find it. Can I do it in my head? That's the question. That equals 40 pounds. All right. So again, free body diagram. Write any forces that you need to. Didn't have to here, but then some of the forces in the X, Y, and Z. Then do a moment in 3 dimensions. After you do all those cross products, then you can break out the X, Y, Z components and figure it out from there.